Hey everyone, thanks for joining me for this Firecast. In the prior mini-series of 3 videos, I talked about how to use JavaScript promises to manage your asynchronous work running in Cloud Functions. But I also mentioned a couple times that TypeScript and ECMAScript 2017 support a syntax called async await that gives you a cleaner way to express sequences of asynchronous work and handle any errors that may occur with that work. If you don't already understand JavaScript promises, be sure to go back and watch those 3 videos, because you'll need to understand how promises work in order to understand async await. Okay, the first thing to know is that there are 2 keywords that work together called, unsurprisingly, async and await. Let's take a look at async first. Async. You use the async keyword to declare a function that always returns a promise that should resolve when some background work is complete. And you use the await keyword to pause the execution of an async function until some other promise is fulfilled or rejected. There's quite a bit more to this, and I think it's easier to understand by looking at some TypeScript code in VS Code. So let's do that. Here's a new Cloud Functions project configured to use TypeScript. First, I'll create a new TypeScript file to play around with, and I'll create a plain function in here that returns a string. When I hover the mouse over the function name, the TypeScript compiler is correctly inferring that this function returns a string, even if I didn't declare it specifically. I can be explicit about the return type by adding it to the function declaration. The function works the same with or without it. Now, if I put the async keyword in front of this function, the TypeScript compiler complains about the return type. It's saying that async functions must return a promise. If I get rid of the return type, then hover the mouse over the function name again, I see the compiler has now inferred that this function returns a promise that contains a string, and there's no compiler errors. Now you might be wondering why there's no errors here. The function internally returns a string, but the function actually returns a promise to any code that calls it. The types don't match. This is because the async keyword is forcing the function to return a promise anyway. What you don't see here is the fact that TypeScript is automatically going to wrap up that string into a promise at runtime, and that promise is immediately fulfilled with the string as a result. Let's look at it another way. The async function you see here returns a promise to the caller, even though internally it returns a string. I can manually wrap the string into a promise with the promise.resolve function. This actually behaves exactly the same way as before, except now I'm being explicit about the promise wrapper. And if I want to be perfectly clear, I can also formally declare that this function returns a promise that contains a string. And it doesn't matter if the internal return value is actually a promise. Love you, TypeScript. So, with the async keyword added before a function, you can indicate that the function always returns a promise, no matter what it returns inside the function. And the other thing the async keyword does for a function is let you use the await keyword inside that function. With await, With await, you can temporarily pause the execution of an async function until some other promise is fulfilled or rejected, then get a hold of its result. Let's take a look at that. Here's the same async function as before that returns a promise that's immediately fulfilled with the string value. Now I'll add another function called getRank that returns a promise that's immediately fulfilled with the number 1. If I want to call getRank from within my function, I can do that here and capture its promise in a constant. VS Code shows that the type of the constant is a promise that contains a number, and if I want to get a hold of the value fulfilled by the promise, all I have to do is use await before that promise, then assign another const to the value it returns. Now VS Code is showing us here that rank is a number, which is automatically unwrapped from the promise. Then I can work with that number without having to call then on the promise like I would without async await. It turns out that the constant rank promise is actually unnecessary, so I'll just get rid of it and use await on the results of getRank directly. This style is common, and it's similar to chaining promises that I showed in a previous video. With async await, you can deal with promises without having to work with promise objects directly. They wrap and unwrap values from promises automatically, which is really convenient. But there's one more thing. Remember that promises can be rejected with an error. So, how can you capture these errors when using async await? For that, you can use a try-catch block, which is very similar to try-catch in Java and Swift. Anytime you use await to unwrap a rejected promise, it'll throw an exception. So, you'll need to catch it if you want to handle that error. Here I'm adding a try-catch block around the use of await to trap any rejected promises during getRank, then return a different string in case that happened. If getRank returns a rejected promise, the catch block will get executed with the value from the rejected promise. For most APIs, this will be an error object, but here it's a string. Now, if I modify getRank to return a rejected promise like this, the string returned from my function would indicate an error. Don't worry, Firebase, you'll always be number one to me. There's just one final thing you need to know about async await. The await keyword is only valid to use within the body of an async function. Anything else is a compiler error. Let's see that. If I remove the async keyword from my function, you can see that VS Code immediately marks the await keyword with an error. If I hover over it, I get a message from the TypeScript compiler saying that await is only allowed within an async function. Async and await must go together. Only async functions have the capability of being paused by await, which is why the compiler complained in my example. You can't just pause any old function with await. The TypeScript compiler gives them special treatment, particularly when transpiling down to a version of JavaScript that doesn't support async await. All right, here's a summary of what you need to know about async await. First, functions marked with the async keyword always return a promise. Second, if the return value from inside an async function is not a promise, it'll be wrapped in one that resolves immediately. Third, the await keyword will pause the execution of an async function until a promise is complete. Fourth, await will do one of two things with the result of a promise. It'll either give you the result from a fulfilled promise or throw an exception from a rejected promise. Fifth and last, await is only valid for use inside an async function. I'm sure you've noticed that the examples I showed you aren't very practical, but now you should have an idea about how async await is structured. In the next video, I'll show you how you can use async await with Cloud Functions by converting those Boston weather functions from my previous videos. I promise you, you won't have to await very long for it. So be sure to subscribe right here to the Firebase channel on YouTube to get notified when that's available. And I'll see you then.